We're
You ready
recording
to go?
this. Yeah, we're recording this one.
All right, so we're going to start with you reading something on page 322 in your textbook. You're going to read about polynomial functions through example 1, and I will actually put that on the screen as well for you, and then we'll talk about it. So let me get it to the textbook as well. So if you don't have your textbook, you should be able to see this, and I'll move it down just a bit so you can read what it says there about polynomial functions through example 1.
What page are you on?
322.
You're just reading that top section down through example 1. I'll have to move my screen up, but you can read that.
Yeah, I'm a pro, Miss McCollum. Don't worry. Thank you. Miss McCollum is now passing out a handout that you will get when you come back. Oh, I don't have any to pass back.
So as you take a look at the top part here, a polynomial in one variable is an expression of the form a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, and you see the dot 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 down to a sub 0. First off, the a sub n minus 1, those are just real numbers. They're the coefficients of the terms in a polynomial. And it's always multiplied by the variable, typically x, but it can be other variables, and raised to a power, which is some positive integer power, or when it's 0, it's really just the constant term. Oh, thank you. And I left kind of...
We put it into a book for now. We'll break it
Oh,
down
okay,
later.
perfect, thank you.
They now gave Miss McCollum her keys back.
So, an example is like these you've seen here below on page 322, and the different types of polynomials have names associated with them, and you will want to learn those names so that you can identify them by name. So a constant term is when the degree of the polynomial is really 0. We might think of it as 12x to the 0. And it's just that the variable is raised to the 0 power, and we know anything to the 0 power is really 1. In a linear function, the degree of the exponent is 1. So we see 4x to the first minus 9. Notice the leading coefficient is 4. That's the coefficient of that highest degree term, which is a degree of 1. You also are familiar with quadratics. That's where the degree of the polynomial is 2, and the leading coefficient of that term is 5. A cubic is when the degree of the polynomial is 3. You can see an example, 8x cubed plus 12x squared minus 3x plus 1. So its leading coefficient is 8. In general, that's just the generic form for any polynomial. Now, I will defer to my PowerPoint here in a moment because I require you to learn the names of polynomial functions through degree 5. They only list through degree 3. So let me put that up here for you for a moment. Oops. And here's just some basic information. These are things you should know about polynomials. A polynomial is in standard form if its terms are written in descending order of exponents, meaning highest degree exponent down to the constant term, which has a degree of 0. The degree of a polynomial is its largest degree of its terms. Each term has a degree, but if it's written in standard form, the largest degree term should be written first, and that exponent is the degree of the polynomial. And the leading coefficient, that's also something of significance, is the coefficient of the first term of the polynomial when it's written in standard form. And so these are the polynomials that you should know based upon the degree. The book goes through degree 3, cubic. You need to write down in your notes, you need to learn quartic and quintic. Those are degree 4 and degree 5 polynomials. You probably already know a constant function is where the degree is 0. Then the linear, degree 1, quadratic, degree 2, cubic makes sense, degree 3. Quartic, degree 4, a lot of you know the prefix quart. 4 quarts equal a gallon, that's a conversion you may know. So a quartic has a degree of 4, and then quintic is where the degree will be 5. After that, we just generically call them polynomials. Questions about any of the names? And this PowerPoint can be found in Canvas, so you can find that information listed there as well. Let me go back to the page in our book to look at example 1, and then we're going to actually do some problems on the purple worksheet I just passed out to you, which is also in Canvas. But as we look at example 1, it says, state the degree and leading coefficient of each polynomial in one variable. If it is not a polynomial in one variable, explain why. So in example A, 8x to the 5th minus 4x cubed plus 2x squared minus x minus 3. Does it look good? Looks like a polynomial. Its degree is 5, which I just said is called what? Quintic. That's a quintic. The largest exponent's 5, and the leading coefficient is the coefficient of that term. And it is written in standard form. Letter B, do you see they've said it is not a polynomial in one variable for an obvious reason? It's a polynomial that has 2 variables, both x and y. It is still a polynomial, but it's not a polynomial in one variable. And then C, it is a polynomial in one variable. Is it in standard form?
No.
Who can tell me what it would be in standard form? What do you think, Chase?
Negative 4x to the 8th plus 3x to the 4th plus 6x to the third plus 2x.
Exactly. The reason you like to have it in standard form is it does make it easier to identify the degree, which is 8, because that's the largest exponent, and the leading coefficient, which would be the coefficient of that term, which is -4. Any questions about what you see there? Now, let's look at the purple worksheet, which I have this in Canvas, if you're watching, and this is the blank sheet, which is right here, and we're gonna do the first 6 problems. We're not going to do every problem on this worksheet. This is not your homework. Your homework's actually in the book, but we're gonna do some miscellaneous problems here to help us understand what we need to do in our homework. You will do the first 6, you will do the bottom 3, and we'll do a few sampling in between. In 1 to 6, it says, state the degree and leading coefficient of each polynomial in one variable. If it is not a polynomial in one variable, explain why. It doesn't have to necessarily be the variable x, you do have to understand that. And if it is a polynomial in one variable, but it's not written in standard form, we're gonna write it in standard form first. That's something I can tell you on your quiz next Tuesday. I ask you to do exactly what you're doing in 1 to 6. So, number 1, doesn't matter that it's not x, it could have been x plus 8 instead of a plus 8. Is that a polynomial in one variable? What do you think, Maria? Yeah, it is. And if it is a polynomial in one variable, can you tell me, is it in standard form?
Yeah.
Yeah, it is. Highest degree down to lowest degree. And they ask you, what is the degree? So the degree is that exponent. What would the degree be for number 1? Yep. A is raised to the first power, so its degree is 1. And then what is the leading coefficient, do you think, Maria?
1.
Yeah, it's 1a to the first. So that is a polynomial in one variable. And then one more question, Maria. What's the common name we use when the degree is 1?
Constant?
No, constant is degree 0.
Ooh, good try.
Linear, yeah, this is called a linear function. You might recall anything of the form y equals mx plus b is linear. Good. Number 2, we have to multiply first. Please do FOIL to multiply the 2 binomials and write it in standard form. And I'll want to know what standard form is. And I will tell you, yes, it is a polynomial in one variable. We don't have more than one unknown. And once we multiply, we'll see it is a polynomial.
In real life, the paper is purple, not green.
Wow.
The commentary from Luke.
Well, because
Thank
it's
you.
green up there, but it's purple right here.
It is.
Mhm.
Yeah.
My lid go. Does anybody see the black lid?
Oh, I see it. It's right by the power strip.
Thank you.
You're welcome, Miss McCollum. I just helped Miss McCollum find the cap to her marker.
You did?
Mm-hmm.
Wow.
What do you have for the product in standard form? What do you think? Do you have it, Lily?
8x to the third minus 4x to the second plus 6x minus 3.
Good. That is correct. I'll write it up here. We have 8x cubed minus
Oh,
4x
shoot.
squared
I put plus.
plus 6x minus 3. That may not have been the order you got when you did FOIL, but when you rewrite, that's the order. So, Lily, what is the degree of this polynomial?
3.
Yep. And how about the leading coefficient?
8.
And if it's degree 3, we would call it what type of
Cube.
function?
Oh.
What type of polynomial?
Quadratic.
That's degree 2, quadratic. Degree 3, when you raise something to the power of 3, what do you think, Luke?
Cubic.
Yeah, it's a cubic function. Just want to get used to those names. Number 3.
Good try though.
Easy. Is number 3 a polynomial in one variable? Yes, it is. Is it in standard form? Yes, I agree. What's the degree, Izzy?
5.
Good. And how about the leading coefficient?
-5.
Good. And do we have a common name for a degree 5 polynomial? Quintic. It's kind of that weird one. I'll put that out here because I don't think I can fit it all in to the right. But degree 5 is called a quintic. Number 4, Tristan. What do you think? Is that a polynomial in one variable?
Yeah.
Yes, I agree. Is it in standard form?
No.
Could you tell me what standard form would be for number 4?
Would be 7y to the 6, negative y, or yes, 7y to the 6 minus y to the. And do I have to make up those ghost terms? Or?
No,
Okay.
no, not when you're just rewriting
Okay,
it.
so then plus 5y to the 2nd minus 3y plus 18.
Good. One of the things on the quiz next Tuesday I have you do is write a polynomial in standard form if it's not already in standard form. Then, like here, we identify the degree and leading coefficient. So what do you think the degree is, Tristan?
6.
Good. And the leading coefficient?
0. Or wait.
The
Oh,
co-
7, sorry.
It is 7, yeah. And do we have a name for a degree 6 polynomial? No, it's
No.
just a polynomial. Yeah,
Is the leading coefficient always the one with the highest degree?
yes. The leading coefficient is always the coefficient of the highest degree term. Whether we had rewritten number 4 in standard form or not, the degree would have been 6 and the leading coefficient would have been 7. It's just a good practice to write it in standard form, which is from highest degree exponent down to the constant term.
So if it was like 8y to the 2nd, then it would still be 7. As the leading coefficient.
If the highest degree term was 8y to the 2nd?
If the highest.
Oh, you mean if
coefficient-
this were
Yeah.
8y to the 2nd?
It would still be 7.
7 would still be the leading, it's not the largest coefficient, it's the coefficient of the largest exponent term. Number 5, yes, Talon,
Oh, I was just gonna
go ahead.
answer. Not a polynomial
And why not?
because variables u and t.
Correct, it contains 2 variables. So it's not a polynomial in one variable. How about number 6? What do you think, Jake?
I think it is, but you have to multiply the equation by r squared.
Here's a question for you. A lot of times people will say number 6 is a polynomial. Thinking about your exponent rules, if we have 1 over r to the 2nd, if we pull that r to the 2nd out of the denominator and write it in the numerator, what would the power of that term be? It would be r to the negative 2nd. To be a polynomial, no variable can have a negative exponent. Meaning if the variable's in the denominator and the term doesn't simplify so that what's left over has a positive exponent, then the answer is no, it is not a polynomial. And it's because of the exponent being negative implied by 1 over r squared. Questions about 1 to 6? That's something I will give you on your quiz next Tuesday. All right, I'm gonna move this down. Everybody have what they want?
What about you, Ava? Do you have everything you need?
Thank you, Luke, for
She didn't answer.
checking. They have the advantage of looking at the answers, which are in Canvas as well. Let me move this up. So in the middle section, what they ask you to do is something we've done before, which is evaluate functions for a particular input. Now, we're not going to do all of these problems, but we'll do a few of them. I'm going to have you look at, let's try number 8, since it only has 2 terms. And number 8 says p of x is equal to 3x plus x squared. So let's start by finding p of -1. So if we have p of x equals 3x plus x squared, and we want to find p of -1, we all understand that means input -1 for every occurrence of the variable x. So we'd have 3 times -1 plus a -1 squared. Do we need parentheses when we square that -1?
Yeah.
Absolutely. If you don't have them, it doesn't mean the same thing. If we simplify that, Maggie, what happens when we simplify?
-3 minus 1 squared.
We have a plus, you have to do the exponent first. The reason I can do both things simultaneously is because multiplication and exponents are both above addition. So most of us would probably multiply and do the power simultaneously, but we should have a plus in between. If you square a -1, Maggie,
+1.
that would be +1. So the second line there should become -3 plus 1, and that becomes what, Maggie? -2. So p of -1 is -2. Let's go ahead and find p of 2, same function. So this time we're going to put in 2 as our input to the same function. So we'd have 3 times 2 plus the quantity 2 squared. See what you get. What do you think, Luke?
I
What
got
happens?
10.
10. How'd you get it?
I did 3 times 2, which is 6, plus 2 squared, which is 4.
And that gave you 10.
Of course.
Yes.
If it gave you anything other than 10, you would be incorrect.
And we know that we can do both multiplication and exponent here before we add simultaneously, because the outcome of the 1 multiplication does not directly affect the power. So that's good. And you've done this before. Let's try where we have some expressions. Number 16 is always interesting because students see -4pa. They actually think this means take -4p times a. That's not what that means. That really means -4 times p of a. And what you have to understand is the p function is right here. You see, p of x is given to us as 4x squared minus 3. If the input is a to that function, that just replaces the x with an a, and that makes the expression become 4a squared minus 3. So when they say -4 times P of A, they really want us to take -4 times the quantity 4A squared minus 3. What's that give us, Talon? What would that become?
Negative 16A squared minus 12, or plus 12.
Plus 12. Does that make sense to everyone? You'll get some extra practice of doing that. I want to give you one more, and I'm going to have you try it. Let me erase this here. So they have given us P of X equals 4x squared minus 3. What I want you to find is P of x plus 2. That might be something you're asked to do on a standardized test like an SAT or ACT, or in your homework, or on a test for me. So what does that mean? That means we're replacing x with the quantity x plus 2. That's your input. So what we have is we get 4, and then in parentheses, we're replacing the x by the quantity x plus 2, and we have to square it. What happens when we square the quantity x plus 2? Think before you speak. What do you think, Jake? If you square the quantity x plus 2, Elijah. Okay, the quantity x plus 2 squared literally means there are 2 factors of x plus 2. What a lot of students mistakenly do is they just square x and they square 2, and they write this. They write 4, and then they write x squared plus 4. And then they do this. But that's a big fat no. That is not what happens. Because you have to square the binomial, that literally means 2 factors of the quantity x plus 2. What do you get when you simplify that, Jake?
X squared plus 2x plus 4x plus 4.
Yeah, the outside product is plus 2x, as is the inside product. In fact, what I do is a little shortcut. I multiply the x times the positive 2, and that's 2x. Notice how that's both the outside and inside product? So I just take the product and I double it so I don't have to get an extra line. I can go from here to here because I know what's going to happen. And I know this is really 2 times that product of the 2 terms. And that's because it's both your outside and inside product. If you wish to use the shortcut, you can. It's a very valuable shortcut.
What is that our answer?
So the answer here becomes this. This becomes 4 times the quantity x squared plus 4x plus 4 minus 3. Simplify it the rest of the way for me. What does that become? Olivia, what do you get when you distribute the 4?
4x squared plus 16x plus 16.
And then we still have the minus 3. So what would that make your final answer?
4x squared plus 16x plus 13.
Yep. Does that make sense to you? Anytime you square a binomial, you got to be careful. It means 2 factors of that binomial. You can rewrite it and do FOIL, or you can learn the shortcut. But please don't just square the two terms. That will not work, ever. Are we good on that? That leads us to the last part of our worksheet at the bottom, and I'm going to move this up so you can see those remaining problems. Luke, you got all that?
Yeah.
The last three problems, they give you graphs. And on the graph, they ask you to describe the end behavior, meaning whether the right and left end is rising or falling. I'll show you how you write it. Then we're going to determine whether the function represents an odd degree or even degree function. And then we're going to state how many real zeros we have. So I'm going to start with the first graph. It's linear. If it's linear, because it's the graph of a line, what's the degree of a linear function?
1.
1. And 1 is an odd or even number?
Odd.
Odd. Notice in an odd degree function that one end's rising, the other end's falling.
Mm-hmm.
That's always true of all odd degree functions. The ends have opposite behavior. One end rises, the other end falls. Now, in our case, we have the right end rising, and I really don't care which part you write first, but because the right end's rising, the way our book writes it is they would say f of x, remember that's just another name for y. So they're saying f of x or y is, if it's rising, going towards positive infinity. It's doing that as x also goes towards positive infinity. As it goes up vertically, the horizontal component is it's going out to the right, which on the right end of the graph, it always should be going towards positive infinity. I always label these because the book tends to write the left end behavior first and the right end behavior second. But there's a reason to do right before left, which we'll come to in days ahead. So, f of x or y approaches positive infinity because it's rising, as the variable x also approaches positive infinity because it's going out to the right. On the left end of our graph, f of x is actually approaching negative infinity because vertically y is going down. It's doing that as horizontally x is going further and further to the left, which means it is also approaching negative infinity. So that's part A. I labeled the first statement R for right end, the second statement L for left end. On the quiz, I do the same thing. Part B is a little easier. Is it an even degree or odd degree function? If the ends have opposite behavior, one end's rising, one end's falling, it's odd degree, which we know since it's a line, the degree is 1 and it's odd degree. This last part says state the number of real zeros. How many places does the graph cross the x-axis? Because zeros are where the graph crosses the x-axis. But how many places does it cross the x-axis? No, it
1.
crosses
1.
right here. It crosses the x-axis in one place, so there is one real zero. Does that make sense?
Yeah. Does it?
Let's try B.
I got it, Luke.
Okay, so let's look at 20 part B. I'll have to write over here. Let's do A first. So we'll look at the right end first. Is the right end rising or falling? Falling, so that means f of x or y is approaching positive or negative infinity. Negative if it's falling. And remember, f of x is just another name for y. So it's approaching negative infinity as x is approaching, and you're on the right end. So as it's falling down, isn't it going out to the right?
Yeah.
Which would mean, is it going towards positive or negative infinity?
Positive.
Positive. And again, that's the right end behavior.
Wait, what? If it's
Question, Chase?
Yeah, why is it, if it's going down, how is it?
It's going down vertically, but horizontally as it goes down, it's getting wider and wider. And as it gets wider and wider, it's opening up, going towards the right.
So if it had like cut back in, like if it had like,
It would have to go that way. One thing you have to know is the right end, x always approaches positive infinity. And the left end, x always approaches negative infinity.
right,
So what changes is what y does. And you can see in the next statement, Chase, is the left end of your graph rising or falling?
the left end of my graph, it's falling.
So it's falling, would that be positive or negative infinity?
It's gonna be negative infinity.
Correct? As x approaches what?
As x approaches, negative, so it's gonna be negative infinity.
Yeah, negative. They're not always the same, but I can tell you for sure, on the right end of any graph, x approaches positive infinity, and on the left end, x always approaches negative infinity. Does that make sense? Part B here, it asks the degree. Do the ends have the opposite or the same behavior? Same, they're both falling. When it's the same, we say the function is even degree. And how many real zeros do you see?
4.
4. It crosses the x-axis. 1, 2, 3, 4. All right, the last one, I have the answers posted. You can check the last one in Canvas. Your homework is also in Canvas. So take a look at that, see what you can do. We'll hold all questions from the synthetic division and this till Monday. Monday's a review day, and we'll answer questions, have time for interims if you need to reassess, at least on one. The quiz is on Tuesday. Luke, did you stop the video?
No, I was waiting for you to sign off.
I am signing off.
Okay, good.
Any last comments?
Yes, Luke had a running commentary.